friends, our next topic is the lexical analyzer generator LEX. Okay, so what is LEX? What is LEX? LEX is a tool or a computer program. Okay, LEX is a tool or a computer program. Okay, or computer program which generates the lexical analyzer, means in the form of tokens identifiers. Okay, so it is used by the YAC parser. Why? Because after the lexical analyzer, which phase we'll get the syntax analyzer. So the first phase we'll call it as a scanner and the second phase we'll call it as a parser. Okay now, so the lexical analyzer will generate the parsing identifiers tokens, then it will enter into the next phase. What is that phase? Parser. What is that phase? We can call it as a syntax analyzer. Okay, then see how the LEX will work. Okay, so the main job of this lexical analyzer LEX is it will break up. Okay, it will break up the input stream. It will break up the input stream. Okay, so how it will break up into in the form of tokens. Okay, so it automatically generated by the LEX program. See, for example, this is you can understand the internal total process, how the LEX program will be executed, how the lexical analyzer will generate the sequence of tokens. Okay, see, I'll make the videos also for running the program, LEX program and YAC program. So for that we have to install the Flex and Bison. Okay, and see, first we have to write our program and we have to save it with lex.l. Lex.l, and that will enter into the LEX compiler. Okay, that will enter into the LEX compiler, then it will generate, automatically it will generate this lex.yy.c. Okay, lex.yy.c. Then that lex.yy.c will enter into the C compiler, then automatically it will generate this a.out file. Okay, so the same location where the lex.file is located, automatically after entering to the LEX compiler, the lex.yy.style file will be created. After that it will enter into the C compiler, then a.out file will be generated. Then the a.out, we have to enter the input stream. With the help of a.out we will get the sequence of token. This is a procedure for the how the lexical analyzer will pass, means it will lexical analyzer will pass the given input stream into the sequence of tokens. Okay, first lex.l will be enter into the LEX compiler, it will generate the lex.yy.c file, then that is enter into the C compiler, then we'll get the a.out. We have to enter the input stream, we'll get the sequence of the tokens. So now see, we will see the structure of LEX. See the continuation of the topic, the lexical analyzer generator LEX. So we will see the structure of the LEX, how the structure of the LEX will be. See, first it will consisting of declaration, okay, and 2% symbols. Then again, so this will be, we will say it as a delimiters, 3 delimiters. Okay, 3 sections, it is separated by 3 sections with 2 delimiters. Okay, then in this phase, in the declaration phase, we will declare the variables. For example, initialization int a, b, c. Okay, and then the next phase, transition rules. Transition rules means it consisting of the patterns and as well as the actions. pattern and action. So here the pattern will be what are the action to be occurred, it will placed in the action. Okay, and the next one is auxiliary function. What the auxiliary function will do means it can be compiled separately and it loaded with the LEX program. Okay, so it contains the it compiles separately and loaded with LEX program. And coming to the transition rules, it have the patterns, and actions. Okay, coming to the declaration, just we will declare the variables. Okay, clear? So in the first phase we will declare the variables, in the second we have patterns and actions. Whatever the operations we are going to do, we will perform in the transition rules. Coming to the auxiliary functions, it will compile separately and loaded with the what are the needed the library files, it will be loaded. Okay, thank you.